Welcome back. Today we're going to be talking about equivalent numerical expressions. Our content objective is students will be able to determine different forms of an expression from a real-world context. Our language objective is students will be able to write numerical expressions to represent context. And why am I learning this? Well, it's important for real-world situations such as finding amounts after a percent of change. So first, let's go ahead and take a look at our very first example. It says, Larry has a piece of rope that's 12 feet long. He cuts 25% of the rope. How long is the rope now? So let's take a look at a tape diagram. Since he is going to cut 25% of the rope, let's look at what 25% of the entire thing would be. Well, if the entire rope is 12 feet, 100% of it would be 12 feet. Well, I only want to cut off 25% of it. So 25% is basically 1/4. So notice this tape diagram is cut into 4 equal parts. So if it's cut into 4 equal parts, each is going to represent 3 to give us a total of 12. So 3, 6, 9, 12. Well, if he's going to cut 25% of it, 25% of this would be gone, meaning 3 feet will be eliminated from the 12 feet. So that's going to leave me with a total of 9 feet. So to write an expression for the length of the rope with a portion cut off, we can think of it in 2 different ways. Okay? So the very first way we can think of it as we're going to go ahead and take 12, because that's what happened. We took the whole length of 12 and we subtracted, okay, the 25% of 12. So we basically took 12 again and multiplied it by 25%. So from there, basically you can distribute this negative 12 or multiply it, whichever way you want to think of it. It's the same thing. You would end up having 12 minus 3, because 1/4 of 12 is 3, which gives us 9 feet. So this is one option. The other option would be to think of it as, hey, I could take 12 and subtract the 25%, or understand if I am subtracting 25%, I am going to be left with 75%. So a quicker way might be just to take 75% of 12. So you can do 12 times 75%, which just so happens to also give you the same answer, which is going to be 9. So your answer would be 9 feet. So you're going to notice here, this expression is equivalent to this expression here. Equivalent expressions are basically expressions that are expressed in different ways, but they do represent the same exact value. So notice these two expressions are not identical. However, they do leave us to the same value, which is going to be our 9 feet. Okay, so notice here, these expressions are equivalent mainly from the fact of using the distributive property. Because if you distribute, in this case, a 12 to 25 hundredths, and in this case, 12 to 25 hundredths and 1, you should end up with the same exact answer. So the distributive property allows this to be equivalent expressions. Okay, so now let's take a look at number 2. It says Joe has a rope that's 25% longer than Larry's 12-foot long rope. How long is Joe's rope? So since it's 25% longer than Larry's, we have to look at Larry's. His is 12 foot long, and since it's 25% longer, I need to know how much 25% is. So just like the last time, we sectioned them out to all be worth 3. Since 1/4 of 12 is 3, so here's your 3, here's your 6, here's your 9 feet, then here's your 12 feet. Well, since Joe is 25% longer, we're going to go ahead and take 25%, which is 3, and tack that on to the 12 feet, which is going to give us a total of 15 feet. So how long is Joe's rope? I would say Joe's rope is 15 feet. Now, let's work on writing an expression to represent that length. So there's 2 ways. The first way would be to take, hey, he has 12 feet, and we're going to add on an additional 25%. So let's go ahead and add 25% of the 12. So notice in the last one, I did switch these two numbers around, the percent and the total feet of rope. I'm able to do that because the commutative property of multiplication allows me to switch the order of the numbers. I still get the same answer, so it doesn't really matter. So here you would simply take 12, add what is a fourth of 12. It's going to be 3. So in this case, I'm going to add them together, leaving me with 15 feet, which is the exact answer that I had from the previous slide. Now, is there another option? There is. Now, the other option would be to understand, first of all, you're going to take 100% of Larry's rope, which is going to be your 12 feet, and you're going to multiply that by the 100% of Larry's plus the additional 25%, which is going to be basically 1.25%. So if you're wondering how I did that, I took my 100%, which would be expressed as 1, and I would take the 25%, which would be expressed as 25 hundredths, add those together, I would get 1 and 25 hundredths. This allows me to understand that it's 125% of Larry's rope, which is 12. And guess what? This would also leave me with the answer of 15. So you're going to note here that these two expressions are equivalent, and I can prove it to you because the answers give us the same exact value. So once again, equivalent expressions look different, but they are the same, or they represent the same exact value. In both cases, we both got 15 feet as the total length for the rope. Now moving on to number 3, it says, for each problem, write both equivalent numerical expressions that will help you find the answer. Number 3, it says the tree in Maria's yard has grown 30% in the last 2 years. If it was originally 12 feet tall 2 years ago, how tall is it now? Okay. So the first option would be to say, hey, it's already 12 feet, so we're going to start with 12 feet. And since it's getting taller, let's go ahead and add 30% of 12 feet. So this would be our first expression. So I'm going to simplify that and say that's basically 12 plus 30% of 12. Basically, let's do some side work real quick. I have some space here, so let's go ahead and do 12 times 0.3. That's going to be a 6, a 3. There's no point in multiplying the 0 because it's going to give me more zeros, so I'm going to move the decimal over 1 spot. And I'm going to get 3.6. So here we have 12, with the decimal belongs at the end, just like the way a period belongs at the end of a sentence, and add 3.6. Leaving me with 15.6. So how tall is the tree now? The tree is going to be 15.6 feet tall. Now that's not the only option. The other equivalent expression to this expression here would be to simply take 12 and multiply it by what? Well, we have to consider the full height of the tree, which is 100%. And since it's growing an extra 30%, we're basically taking our 100%, which would be expressed like this, and then our 30%, which would be expressed like this, which is basically taking 130%. Now, if I take these two numbers and multiply it, let's go ahead and, there's not a lot of space, so we can go ahead and multiply it right here. Let's do 12 times 1.3. Here we have 6, 3, 0, 2, and 1. So that's 6, that's 5, that's 1. Move our decimal 1 place over. Oh, look, our answer is still the same, 15.6 feet. So here is just further proof that these two expressions are indeed equivalent because we do have the same exact value for an answer. So to answer the question, how tall is Maria's tree? I would say the tree is now 15.6 feet tall. Now, real quick, we should assess to check whether or not our answer makes sense. Since the tree did grow, we do expect it to be taller than 12 feet. Is it? Yes. Now, if for some reason, if it was smaller than 12 feet, I know for sure something went wrong. I made a mistake, and I'm going to have to fix it. So please keep those things in mind. Okay, now let's take a look at number 4. It says, Paulo can run a marathon for 4 hours and 20 minutes. If he's able to cut 20% off his time, how long will it take him to run a marathon? So the very first thing that I want to do is understand they gave me two different units. They said 4 hours and 20 minutes. So in order to actually take 20% off of his time, I'm going to want to make sure the time is expressed in one unit and not two different ones. Because again, right now it's in hours and minutes. So the easiest thing is always to convert to the smaller unit. So what's smaller, an hour or a minute? Minutes are smaller, so let's convert everything to minutes. So here, 4 hours would basically be 4 times 60 minutes, which would leave me with 240 minutes. So 240 minutes plus the 20 minutes here is going to give me a total of 260 minutes. So if he's able to cut off 20% off of his time, the first thing I would want to do, first option, would be to take 260 minutes and subtract 20% of the 260 minutes. So that would be 260 minus. Now, let me let you in on a tip. What you could do for a case like this is simply take the numbers as if they were whole numbers. So this is counted as a 2. Multiply it out. And then count how many decimal places are. There's only 1, so I'm going to move it over once. So it's just 52. So we're not done. We do want to simplify that one step further. If we take 260 and subtract our 52, we are going to end up with 208. So which means if he's able to shave off 20% of his time, he can run it in 208 minutes. Now you could take this a step further and convert it back to some hours and minutes. It's just a matter of asking yourself, how many minutes will fit, how many 60 minutes will fit into 208? Now, do you really have to do that? No, but let's just go ahead and practice real quick. This is going to go about 3 times, and that's going to leave me with a remainder of 28. So it's going to be 3 hours and 28 minutes. Now, again, is this necessary? No. So real quick, this is the very first option, which is taking it and subtracting the 20% to show that that's how much time is being shaved off of his original time. But the other way to think of it is thinking it as, hey, you could think of it as taking 260%. Instead of taking 20% and subtracting that from my original 260 minutes, I can go ahead and simply think of it as, hey, let's just calculate what 80% of that is. So if you're wondering how I got 80%, I'm basically taking 1 and subtracting the 20%, which leaves me with 260 times 80%, which is going to still leave me with an answer of 208 minutes. So again, this is further proof that these two expressions are equivalent because our answer is going to be the same. The values are the same. Okay, guess what? It is now your turn. What I'd like you to do is go ahead and pause the video and try number 5 by yourself. Okay, so let's check how well we did. So for Joe's snowboard, it was 140 centimeters. Carly's is 14% longer. How long is Carly's snowboard? So one option would be to take the 140 centimeters, and since it's longer, we're going to go ahead and add 14% of the 140. Now, real quick, when you're writing your percent, you generally would want to keep a 0 in front to kind of keep things nice and neat. So just quick tip. I'm going to go ahead and take 140 now and add this together. Let's multiply that. We're going to do 140. Let's just multiply it by 14. 0, 16, carry the 1, which is 5. Then we have a 1, 4, 1. And that's going to leave us with this. Then count, there's 2 decimal places. So that's going to be 19.70. Now we're not quite done yet. We still want to add that to the 140. So I'm going to go ahead and put that right underneath, making sure I line up my decimals, which is going to give me a total of 100 59 and 7/10. I don't need that 0 at the end. Centimeters long. Okay, now is there another option? The answer is yes. The other option would be to simply consider, okay, instead of taking 140 and adding 14% of that, I could understand that Carly's is just basically 114% of Joe's snowboard. So we're going to take 140 and basically say, well, we're going to have to consider the 1%, which is basically a 1. If you're wondering why I'm writing it like that, it's because if you take 100% and you move your decimal 2 places, that's why you would have the extra zeros. Now, is it necessary? No, but I just want to kind of show you where that's coming from. Now, so you're going to take 100% of Joe's snowboard, but you're going to tack on 14%. So we're going to add 0.14, which is going to give me a total of 140 times 1 and 1400ths. Now, if you actually multiply this out, you're going to find that you still have the same exact answer. So let's see this. 0, 16, carry the 1, 5. That's going to be a 0, a 4, and a 1. Put 2 decimal places. Then we're going to have a 0, 4, and 1. 6, 9, 5, 1. Move the decimal places 2 over. And oh, look, we still have the same answer. Wait, I just realized I made a big mistake right here when I add the 0. Oh, 1 times a 0 is a 0. So this should be a 6, not a 7, which then now this would actually match up. So I did make a mistake, so please make sure you make those corrections in your notes. This does also give me a total of 159 and 6/10 centimeters. Further giving me proof that these two expressions are equivalent. Again, I did make a mistake here. I accidentally put a 7. Please fix that to a 6 to show that these indeed are equivalent. Okay, so again, whoops, I made an error here, but hopefully you fix that and you see that these are the same exact value. Okay, so now we're going to talk about something called markup and discount. For number 6, it says an item is normally priced at $400. The item is then marked up 23%. Write 2 numerical expressions to find the price of the item after the markup. Find the price after the markup. So markup is basically an amount added to the cost price of the item to cover overhead and profit. So if you think about it, if you have your own company, you might buy certain things and you want to, of course, sell it for more than what you bought it so that you can actually earn money. So that is what you would consider a markup, is how much are you pricing it on top of what you bought it so you can make a profit. So we have 2 options. One option would be to take the 400 and add 23% of $400. So if you do the math, you're going to get 400 plus here, we're just going to do 400 times 0.23 and go ahead and multiply 0, 0, 12, 0, and then 0, 0, 8. Hopefully I'm multiplying correctly this time. Moving my decimal places 2 over is 92. So it's going to cost $492 after the markup. So basically, if you think of it, how much are they profiting if they bought it for $400? They're profiting $92, which is pretty good. Now, there is another option. Another option is understanding that if you want to do a markup of 23%, you're going to have to, of course, take 100% of the price, and then you're going to go ahead and add your extra 23% to that. So you're going to be doing 400 times 1 and 2300ths. Now, if you multiply that together, you would still get, and I'm just going to go ahead and double check on a calculator to make sure I multiplied correctly. If I take 400 and I multiply by 1 and 2300ths, you do end up with a total of 492. So this is further proof that these expressions are equivalent. They do look different, but they do leave us with the same exact value. So the answer to the final price for the markup would be 492, and these would be our two equivalent expressions. Okay, so now let's take a look at number 7. Number 7 is slightly different. For this one, we were talking about a markup. The price was going up. Now this one is going to be talking about a discount. So let's take a look. It says the cycle store has a bike regularly priced at $660, and Tom negotiated a 30% discount. Write two numerical expressions to find the price of the bike after the discount, and then find the price. So the very first option is just to take the $660, and since it's a discount, go ahead and subtract 30% of that $660. So basically, you're going to take 660 and distribute. You can think of it as distributing a negative 3/10. And you're going to go ahead and subtract that. Let's do some side work. 660. Let's just multiply it by 3 for a second. And then move the decimal over one spot. So he's basically saving $198. So that would be the discount. So understand, if they're asking strictly for a discount, this would be your number. But because they're asking to find the actual price, we're going to go ahead and take that discount off. Make sure I'm lining up my decimals, which here they're just whole numbers, so you really didn't have to. Oops. And here we're going to borrow. This is going to be 2. We're going to borrow again. And we're going to get $562 as the final price for the bike. Now, is there another option? Absolutely. The other option would be to think of it as, hey, if it's $660, instead of saving the 30%, you can think of it as, I'm paying 70% of it, right? So again, I'm going to say that one more time. Instead of thinking of it as, hey, I'm saving 30% of the price, you can just consider it as, if I'm saving 30%, that means I'm going to end up paying 70% of the price. So if you're wondering how I did that, I'm just taking 1 and I'm subtracting the 30%, which would give me 660 times 70%. And here, let me just go ahead and plug it into a calculator real quick to just double check that I multiplied everything correctly. And I did make another mistake. It is not $562, it's actually $462. And here I can see my mistake. It was 5 minus 1, which is not 5. It is a 4. Okay, so notice here I'm making my own mistakes. You want to just be careful that you're not making silly errors like I am doing now. Please double check your work and make sure that you're not making silly errors like that. So either way you solve it, you're still going to get an answer of $462. This is further proof that these expressions are equivalent. Okay, so now for number 8, it says below are 4 expressions. Circle the 3 that are equivalent. So the best way to prove if something is equivalent is simply evaluate it or simplify it. So in this case, what you can do is simply simplify this expression, see what the value is, and check to see if there are any other values that all match each other. Because if they do equal the same value, then I know they are equivalent. So here, I'm going to go ahead and solve what's inside the parentheses first. If I take 1 and subtract 3,500, I am going to be left with, let's see, 1 minus 3,500. We're going to make this a 10, a 9, and a 0, 5, and 6. So we're going to be left with 6,500 times 423. I'm obviously very good at multiplying accurately, being sarcastic if you didn't catch that. So I'm going to go ahead and just multiply in a calculator to double check. And that's going to give me a value of 274 and 95 hundredths. Now, notice these two numbers are identical to these two numbers, so I'm pretty sure this is also going to equal 274 and 95 hundredths. Now here, what you're going to want to do first is, you can think of it as 2 ways. You can distribute that negative or just distribute this and subtract. So let's go ahead and say this is 423 minus, I'm going to go ahead and plug in the calculator so I don't give you any wrong numbers like I have in the previous problems. So that's going to be 148 and 500. So if I simplify that, let's go ahead and do 423 minus 148 and 500, which is going to give me a total of 274 and 9500. Notice all three values are identical at this point, so far I know A, B, and C are equivalent. Let's check the last one. This one I'm going to show you by hand. Let's go ahead and do 423, decimals at the end, just like appears at the end of a sentence. And we're going to go ahead and subtract our 3500s here. 5 cannot be subtracted from 0, so we're going to have to borrow. That's going to be 5, a 6, this is going to be 3, a 2, and a 4. So that's going to leave us with 423 and 6500. This is not equivalent to these three other values, so I would not circle 3 as an option. Now for number 9, what I'd like you to do is go ahead and pause the video and try this one by yourself. It says here, Josh made 5 3-pointers and 4 2-pointers at his basketball game. Write a numeric expression to represent how many points Josh scored. So go ahead and pause the video and try this one by yourself. So someone might express this as 5 times 3 because there are 5 3-pointers, and 4 times 2 because there are 4 2-pointers. Now someone else might see it as, well, if there's 5 3-pointers, I'm going to write 3 5 times. There's a 3-point there, another 3-pointer, another 3-pointer, till I get a total of 5 3-pointers. And there were 4 2-pointers, so we're going to write 1, 2, 3, 4. Both of these would work, and I know that they are equivalent because why? If I were to simplify these, they would give me the same exact value. So let me show you. 5 times 3 would give us 15. 4 times 2 would give me 8, so this is 23 points. Here, if I add the 3's, I would have 3, 6, 9, 12, 15. 15 plus 2 is 17. Plus another 2 is 19, plus another 2 is 21, plus another 2 is 23. I can clearly see that these are the same exact value, so I am certain that this expression here is equivalent to this one. Now, is one superior than the other? I'm going to say no. However, I do think when I'm simplifying it, this may be a lot quicker than me adding all of these numbers out. Now, is it wrong to write it out like this? No, in fact, I think this makes it a little bit clearer for you to understand. There were 5 3-pointers and 4 2-pointers. So all you need to understand is expressions can be equivalent when they represent the same exact value. Guess what? That's going to conclude the lesson for today. Thank you so much for tuning in, and as always, until next time, bye!